Welcome to UG Academy. This is our 19th lesson on Python. Today we are going to conduct a project that sums up what we have learned so far. So let's first have a look. This is a console program which allows the user to play tic-tac-toe. So as you can see, it displays a tic-tac-toe board here, and then we can input the place we want to move on the console. For example, A1. After our input, the console will refresh and add a clause on the position A1. And then it's time for the circle to move. For example, we enter the coordinates B1. And then the console will refresh again and put a circle on the position of B1. Similarly, it's now time for clause to move. We can, for example, type in A2. Now we will put a clause here. Suppose the user has made some input error. For example, now it's circle's turn and it input A1. However, A1 is already occupied by the cross. So you can see the program will display an error message and request the user to input again. And suppose now circle put on B2. And then now cross put on A3. Okay, as you can see, after putting a cross on A3, the cross sign has wrong, and then the program displays a message, and then it returns to the console interface. So this is how our program will work. If all the grids are filled and there are no winners, we will display a draw message. Okay, let's have a look at the program. I've already written out the entire program here. It consists of two files, the main file and then a game file. The game contains a class we called board. It serves as a useful object that help the main program to run and to conduct this game. In this video, we will first have a look at the board. We will first have a look at the broadcast. Okay, it seems quite complicated here, and it's in fact it has more lines of code compared to any program we have written previously. So let's start here. Part by parts. Okay. First, we define a class called board, which will serve as an object that represents the board. And then in the initialization function of the class board, we define the state attribute of this object. The state attribute will be a list of a list using list comprehension. This here, you can see this is the outer list, and then this is the inner list. Using list comprehension, so it will be a list, a 2D list of string. We will first put it as empty string. Empty means there is no clause or circle at the position. And then it's horizontally free grid and then vertically free grid. Okay. The innermost we treat it as the innermost is horizontal, and then the outer list is vertical. And then we would like this bot to be able to perform some function. For example, we would like this bot to check if there is a winner. So we define a function for this bot. We all know the rule of tic-tac-toe, right? If we obtain a 3 in a row, then the player wins. So we define a check winner, have winner function. It will be a Boolean function. If there is a winner exists on the board currently, it will return true. If no one has won currently, it will return false. It doesn't matter if it's a circle or cross win. As long as somebody wins, it will return true. Okay. Why do we not need the information of who won? I'll explain this later in the main function. For now, just know that this function returns the value of whether there is somebody have won. First, we check for the rows and columns. We use a for loop to iterate through the row and columns. Since there is 3 rows and 3 columns, the loop will run for 3 times, and then for and then within each loop iteration, we will check for one row, and one column. First, we check whether the intersection points of the rows and columns we would like to check is empty. If it is empty, nobody has one on that row and column. So, and then we define two Boolean values called row and columns, indicate whether somebody has formed a 3 in a row on the specific row. And then the function is not that complicated. It first states that if the first grid of the row is equal to the second grid of the row, and the second grid of the row is equal to the third grid of the row. This essentially means that all 3 grids within that row have the same state, either circle, cross, or empty. Okay. Similarly for the row as well. Okay. Note that this is the y coordinates and this is the x coordinates. Okay. The first number is the y coordinates of the board. Okay. And then if it's non-empty, and then either row or column has fulfilled the requirements, that means that the state within the 3 grid are the same and it's not empty. That means somebody occupied the 3 grid within that row or column, and then you return true. But this is not enough, because we can also have the diagonal 3 in a row. Therefore, we are going to check for the diagonal as well. The check for diagonal is similar to the check for row and columns, but instead of using a for loop, since there is only 2 diagonal, we will directly check them one by one. Similarly, the intersection point cannot be empty. And then we also check in a similar fashion using the Boolean statements here. And then at last, we check whether the condition fulfilled. If the condition fulfilled, somebody win using a diagonal. If not, that means nobody have won. So we return false. Okay. So this function is for checking whether there's a winner existed on the current board state. Now we are going to implement a function that allows we change the state of the board. It's called move. It will be called in the main function here, in the main program here. It is a function that takes in 2 arguments. The self argument doesn't count as arguments because it's a default argument for method for an object. Okay, so these 2 are arguments that we are going to pass in from the main program. It specified the program. It can specify the player that is going to move and then the position of the move. Both of these are string, and this can either be circle or cross, and this will be a string A1, A2, something like that. Okay. Before we implement this method, I'd like to add two dictionary as attribute to our objects. Add them at the initialization function. So what is this? This xcore is dictionary. Okay, and this ycore is also a dictionary. It will map the string indicating the coordinates to the actual index within the state list. Okay, that is ABC corresponding to the index within the list as 0, 1, 2, and then 1, 2, 3 as string correspond to the index within the state as 0, 1, 2 as well. X coordinates mean the horizontal axis, and Y coordinates mean the vertical one. Okay, we'll use these 2 dictionary to map the user inputs into an index that we can input into the state using this form. If you are not aware of this syntax, it's called dictionary comprehension. is similar to list comprehension, but this time we use key value pairs for composing this dictionary instead of a single item for list. Okay. So let's see how we do with the move method. First, since this position string is going to be the user input we have from the console, we is going to do some pre-processing. For example, this L strip, it means that it remove any excess space, before the user input, because the user may accidentally type some space. If we don't remove them, we may have error later on. Similarly, for this upper method, it's also a predefined method for Python string. Position is a Python string, okay? It will convert all lowercase alphabets within the string to uppercase. The reason we are doing this operation is because in our dictionary, we are using uppercase for mapping. If the user input lowercase, we need to perform this conversion before we can actually fit into the dictionary to get our coordinates. Okay, then after doing this processing, we can fit the string into our dictionary. For example, the x coordinates will be the first input of the user, ABC, and then the second coordinates will be the second input of the user, like 1, 2, 3. Okay. So after doing the mapping, using this self function, using this self dictionary for the self, and then we get the index within our state, which is xy. Then we check if the state that is the state of that grid is empty. If not empty, it will raise an exception. Okay, this exception is going to be catched by the main program and handled in the main program. Otherwise, we assign the player that would like to move there to the corresponding grid in the board. So this is how this broadcast work. With these 4 methods, it can already run a game very smoothly here in the main program. So although tic-tac-toe is not easy, but since we have already written many codes here, so the main program is actually quite short. We are going to talk about the main program in our next video. Thanks for watching.